It is now time to start thinking about building connectivity in our network. We will accomplish this by configuring firewall interfaces. You can think of an interface as of a point where the traffic enters the firewall or leaves out of the firewall after being processed. So it's an entry point to the firewall for the traffic so it can get processed, so it can get inspected, and when the firewall says, I'm okay with those packets, I will allow them to leave through typically a different interface from what they entered the firewall on. Now, there are a few different types of interfaces that are available on PenOS. You could configure them as layer 2 ports, as layer 3 interfaces. You can do VLANs, you can aggregate those ports, but we will take a look at a simple case where we will just use the most typical, the most common interface type known as layer 3. Also remember that a given interface will never process the traffic unless it is assigned to a so-called security zone. Now the question is what a security zone actually is. And now security zone is something that is gonna make a logical boundary that the firewall is gonna use to eventually control the communication. Now the idea behind security zones is that we will use them to segment our network into those more trusted or less trusted portions, and the traffic is only going to be allowed between these different zones, assuming that the firewall's policy allows for that. So for instance, we can create a security zone called inside, which is meant to be connected to trusted devices like our internal users. We can have another security zone called outside, external, or internet, which will be connected to the external world, typically the internet. We can have other zones for specific device types, like for instance for special user departments, maybe human resources, maybe security operations. We can have a security zone for certain applications or servers, like for DevOps, test applications, the test servers, and similar. So the idea is that the more security zones we have, the easier it is going to be to break down the whole communication, make it more granular in terms of inspection and control with the aid of security policy. Because as we will see, security policy is going to be made of rules, where one of the main conditions that will be used to define those rules is going to be security zones. So in general, the more security zones you have, the more granular control you will be able to enforce on the firewall, but more administration rules it is going to require. Another important point about security zones is that they are related to the implicit firewall behavior. This is related to the default filtering logic of the firewall. As we will see later in this course, the firewall uses two implicit security policies, security rules, one for infrazone and one for interzone communication. So what's the difference between them, and how is this related to the concept of security zones? For instance, assuming that we would configure security zone called in for interface 1/1 and use a different security zone like out for Ethernet 1/2, the communication between these two interfaces, since they are part of different zones, would be classified as interzone communication. And the default behavior of the firewall for interzone traffic is to drop it. So this means that without defining any custom or just specific security policy rules meant to explicitly permit communication from the inside to outside or outside to inside, the firewall would always drop communication that is trying to traverse through these two interfaces, through these two zones. And now, on the other hand, if we were to use the same zone on these two ports, like for example, inside and inside on both interfaces, that would be treated as intrazone traffic. I mean, the traffic that would be traversing from these interfaces, which based on the implicit or just default firewall policy would be allowed. So that communication would be permitted. And because of that, it is very important to carefully plan configuration of security zones and their assignment to the interfaces. Here also remember that a single interface can only belong to one security zone. You cannot assign more than one security zone to a single interface. The firewall is not going to allow that. It is always going to override a zone with the new setting. So single interface equals single security zone. Remember about that. We will now configure interfaces and zones on this firewall. This is something that we can do from the Network tab. You guys don't forget to subscribe if you like our content. Thanks! Let's switch to network and start with zone definition, because zone is something that we will then want to assign to interfaces. So under network and zones, I'm gonna say add, and I will call my first zone in, where I'm gonna set the type to be layer free, because I will be using layer free interfaces, and we will accept. And then we will configure another zone called out, still at layer free. Okay, and now with zones in place, we can go to interfaces and start configuring them one by one. And based on our topology and also what I mentioned earlier, we will want to use the in zone for Ethernet 1/1 and then out for the second interface. So let's start with 1/1. We will give it an IP address of 10.1.1.10/24, where the outside interface is gonna get 192.0.2.10/24. So this is what we want to configure. Moving on in this portion of the course, I'm going to go to the interface, click on it, and the first thing that I want to set here on the port is going to be the interface type. Remember that my zone was configured as layer free, which means that my interface, in order to take the zone, it must be also configured as layer free. And the reason that I'm using layer free interfaces is that the firewall will be essentially routing packets between our different zones. Okay, there is also a concept of so-called virtual router. At this point, you can just think of it as of the routing table. So assuming that we want all these interfaces to be part of a single routing table, we will just make them part of the same virtual router. And there is a default virtual router called default, so we will use it. We will not be building a dedicated virtual router instance. Next, I want to specify the zone. I want to set it to in and configure an IP address on this firewall. This is going to be a static address, 10.1.1.10/24, and we will just OK. And we should see that the interface, the link state of this port, is going to eventually turn green. Let's also configure Ethernet 1/2. It's going to be the same process. What I will take to finish this configuration, I'm going to start with the type, layer free, virtual router is set as default, and security zone, in this case, we will use the out zone, and of course an IP address will also change to 192.0.2.10/24. Okay, so let's refresh. At some point we should see, once they commit the configuration, we should see that these interfaces will eventually come up. Just one more thing before we commit, I want to go back to device setup services. Remember that I also said that in order for the firewall to communicate with external services, in order to force it to use something different than the management port, we want to explicitly configure a service route. So again, we want to define service routes for NTP and DNS to use the outside interface. So for DNS, I'm going to choose Ethernet 1/2, the outside interface, and we will do the same for NTP. Use an outside port. And we will now commit to install this configuration. We will now have to wait until the firewall installs these changes. And when this configuration becomes active, we should be able to eventually test connectivity. Okay, so now we can tell that the link state is green, which means that the interfaces are up. I'm going to go to the firewall's command line, and I'm going to use the ping command, where I'm going to specify the source. In case of PanOS, you want to specify the source to make sure that the firewall uses the right interface to generate ping packets. And we will try to ping router 1 from Ethernet 1/1, and then router 2 from the outside port to confirm connectivity. So 10.1.1.10, this is my inside interface, and I want to ping a host 10.1.1.1, which is router 1. We see that we have connectivity, and let's also try to ping from 192.0.2.10. Try to get to router 2, which is on the outside. We have connectivity here as well.